Alright guys, so this is the answer key video for homework number 4. So let's get started with problem number 1. Let f of x equal 4x minus 6. If f of a equals 12, determine a. So looking at this function, most important thing is classifying input and output. Because a is in the parentheses, a is the input, 12 is the result, so 12 is the output. So let's see, when we input a into the function, it gives us an output of 12. So once we create this algebraic equation, all we have to do is solve for a using inverse operations. So let's add 6 on both sides. We get 4a equals 18. We divide by 4 on both sides. And we get a equals 9 halves after we reduce that fraction. So that's totally okay to get a fraction. Looks good. Next up, we've got f of 12 equals b. So really similar problem, but it looks like this time 12 is the input because it's in the parentheses, and b is the output. So when we input 12 into the function, it becomes 4 times 12 minus 6 gives us an output of b. So this is a weird looking equation because b has already been isolated. So the only thing we have to do is simplify this side. So we get 4 times 12 is 48 minus 6. 48 minus 6 is 42, so b must be 42. Okay, taking a look at problem number 2. Let g of x be the function defined by the data in the table. To determine the average rate of change of g of x on the interval from 1 to 4. So when x is between 1 and 4, it looks like we're talking about these 2 points. So one of the most important things we talked about in class today is that average rate of change actually just means slope. So even though this function g of x is not linear, sometimes it goes up, sometimes it goes down, we're still going to apply that idea of slope to the 2 values that we circled, or the 2 points that we circled. So because we're using values from a table, we're going to use the slope formula. So slope is equal to y2 minus y1 over x2 minus x1. Now substituting in from the problem, m is equal to, remember that g of x is the output, so this is y, and the x value is the input. So let's see, y2, x2, y1, x1. So we have 3 minus 24 equals 4 minus 1. So we find that m is equal to negative 21 over 3, m is equal to negative 7. Next up, we've got question B, so I'm going to change colors to pink. Determine the average rate of change. Key phrase means slope on the interval from 0 to 6. So this time we're looking at from 0 to 6. So let's see, because we have points, again, we're going to be using the slope formula. So m is equal to y2 minus y1 over x2 minus x1. M is equal to, this time, y2, x2, y1, x1. We've got negative 1 is the second y value, minus the first y value is 17 over the second x value, minus the first x value. So we get m is equal to negative 18 over 6. M is equal to negative 3. So finally, for part C, we need to identify on which of these 2 intervals is the rate of change greater. And it's a sneaky question, right? Because both rates of change are negative numbers. So when we compare them, negative 3 is actually a larger number than negative 7 because it's less, it's less negative. So it's a larger number. So the rate of change from part B is the larger value. Okay, next up, we have a really similar question. The function f of x is graphed below. Determine the average rate of change of f of x on the interval from, and the interval negative 6 is less than or equal to x is less than or equal to 2. So because they gave us this information graphically, we need to find negative 6 for x. So negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. So that will be starting here and ending at 2, which is here. So we can use the 2 endpoints of that interval to find the slope of this line. So the slope of that line is going to be 1, 2, 3, 4, 5, 6. So up 6, and then across, rise and run. So this is the rise. The run will be 1, 2, 3, 4, 5, 6, 7, 8. So our slope is going to be rise over run, which in this case turned out to be 6 over 8, which can be reduced by 2 on top and bottom, so we get 3/4. Okay, for problem number 4, let f of x equal 8x minus 2x squared. Determine the average rate of change on the interval between 2 and 5. So because they didn't give us the graph this time, I'd like to use the slope formula, y2 minus y1 over x2 minus x1. But the challenge in using the slope formula is that they only gave me the x interval. So I know that x starts at 2, but I don't know the y coordinate. And I also know that we're going to look when x is 5, and I don't know the y coordinate there either. So the first thing I need to do to use my slope formula is I need to actually find these two missing y coordinates. So to find them, I'm going to start by finding the y coordinate for 2 by plugging 2 into the function. So I have 8 times 2 is 16. 2 squared is 4. That becomes 16 minus 8, which is 8. So the y coordinate for this point is 8. Similarly, over here, if I plug in 5, I get f of 5 equals 8 times 5 minus 2 times 5 squared. This is 40 minus 2 times 25. This is 40 minus 50. This is negative 10. So when we plug 10 into our formula, 5 into our formula, we get a y coordinate of negative 10. The last thing that remains is to actually use the slope formula. So because this is our second point over here, this will be y2 and x2. Our first point over here, so this is the y coordinate of the first point and our x coordinate of the first point. So our formula becomes m equals negative 10 minus 8 over 5 minus 2. M equals negative 18 over 3. M equals negative 6. Consider the 3 functions below, f of x, g of x, and h of x. So we have 3 different functions here. Okay, so I'm going to draw those barriers in. We've got this pink function, f of x. We've got this green function, g of x. And we've got this red function, h of x. So we're going to be comparing their rates of change. So let's start with the pink function. So the correct list, I should read the question. The correct list of functions ordered from greatest to least by average rate of change over this interval is. So in order to order them from greatest rate of change to least rate of change, I need to actually find their average rates of change. So I'm going to start by finding the average rate of change for f of x. The average rate of change for f of x on this interval would be using this coordinate and this coordinate. So I have y2, x2, y1, x1. So I use the slope formula, 7 minus 1 over 3 minus 0. So I find that m is equal to 6 over 3, which is 2. Now for our green function in the middle, we've got g of x equals x squared minus 2x. I'd like to use the slope formula again, but in order to use this, I actually have to find the entire points, since they didn't give me the table. So I need to plug in, for x, I need to plug in 0 and 3 and find the matching y values. So when I plug in 0, 0 squared minus 2 times 0, that's 0 minus 0, that's 0. When I plug in 3, I get 3 squared minus 2 times 3. 3 squared is 9, 2 times 3 is 6, so I get 3. So that's pretty remarkable that both of these x and y values and both of these x and y values matched. But the math proves it. So we have y2, x2, y1, x1. So you have 3 minus 0 divided by 3 minus 0. We get m is equal to 3 over 3. And any number divided by itself is 1. Next up, we're looking at the red graphical function. We need the rate of change on the interval from 0 to 3. So zooming in here, let's draw in our line. So rate of change here is probably easiestly found using the graphical method. So we rise 1, 2, oh, that's confusing, 3, 4, 5, 6, 7. So here it's 7 over 3. So my rate of change for this function, let me put it down here so it matches, is 7 over 3. And it might be hard to compare this fraction that we just found to these two whole numbers. So if you use your calculator, or maybe you just know how to do it with your brain, you can divide these two and you get 2.33333 forever. All right, so we have our 3 rates of change. And I prefer this one as a fraction, but for comparison, I think that it works better as a decimal. So it looks like out of all of these, this is the largest number, so we want h of x first. After h of x, we've got 2. That's the second largest number. So that's f of x. And then finally, we have the green function here, the smallest rate of change, the least rate of change. So that's going to be g of x. So that must be answer choice 4 when we compare all of them. I know this video is getting long, but I want to do the challenge problem. The challenge problem looks really cool to me. So let f of x equal x squared. Determine the average rate of change of the function on the interval a is less than or equal to x is less than or equal to b. Your answer should be in terms of a and b. All right, so really similar to the problems we've been doing, but they didn't give us a number. So I want to use, I think, the slope formula, right, since I can't really graph a and b. So I want to use y2 minus y1 over x2 minus x1. But they only gave me the x values. So it looks like I start at a and I end at b. So I need to find the accompanying y values. So we're going to plug a into this function. When we plug a into x squared, it just becomes a squared and there's nothing we can do. When we plug b into this function, it just becomes b squared and there's nothing we can do. So it looks like the slope is going to use these things that have variables. It's going to become a literal equation. So substituting into our slope formula, we have y2 and x2 and y1 and x1. So we have b squared minus a squared over x2b minus a. And if you got this, you should be really proud. But there's actually one thing you can do to simplify this. So I don't know if you remember from Algebra 1 last year, but the numerator of this fraction is a difference of squares factoring pattern. And so you can write this as b minus a times b plus a. And if you distribute this out, that will give you b squared, ab and minus ab cancel out. And then negative a times a gives you negative a squared. So this factoring pattern is a difference of squares. You may have seen this last year. You should have seen it last year. But this is a hard application of it. We'll talk about this later this year, but that's why it's a challenge problem. And it'll be over b minus a. And the really nice thing is after you factor the numerator, you can see that this factor and the denominator match, so they cancel out, and you find that the slope will be m equals b plus a. A really nice, simple answer. Maybe even better looking if we write it in alphabetical order using the commutative